Isn't it mind-blowing how vast and mysterious our universe is? It's a source of wonder and, at times, disappointment. Imagine peering through our most advanced telescopes and spotting a planet perfect for life, only to realize that reaching it would take centuries. Our home, Earth, is just a tiny speck in the Milky Way galaxy, and the closest neighbor, Andromeda, lies a staggering 2.5 million light-years away. If we were to send a mission at the speed of light today, it would still take 2.5 million years to reach Andromeda. It's undeniably disheartening. But what if I told you that there's a possibility of finding shortcuts through the vastness of galaxies? These cosmic shortcuts are known as wormholes. Yes, you heard it right. Now, before you think this is pure science fiction, let's dive into the real science behind wormholes. To understand them, we must revisit the groundbreaking theories of Albert Einstein, specifically his theory of relativity. Einstein proposed that matter and energy can warp the fabric of spacetime, much like placing objects on a mesh causes it to curve. Imagine this mesh representing spacetime. The stronger the gravitational force of an object, the more it bends this mesh. In 1916, Karl Schwarzschild cracked the code and found the solution to Einstein's field equations. He showed how the spacetime mesh curves around a massive object like a planet or star. But here's where it gets intriguing. If this mass were to become infinitely dense, the spacetime curvature would pinch off from the universe, creating what we now know as a black hole. Black holes were theoretically explained a century ago, but it wasn't until 2019 that we got our first glimpse of one. However, those same field equations had another solution: wormholes, scientifically known as Einstein-Rosen bridges. Picture this in 2 dimensions. Think of a straight line connecting point A and point B. Now, bend a 2D piece of paper into a 3D mesh, and suddenly, a path through the 3rd dimension becomes the shortest distance between those points. In 1957, the brilliant scientist John Wheeler described this concept using an apple and a worm. Instead of the worm traveling on the apple's surface, it bores through, creating a shortcut. That's precisely how the term wormhole came to be. When a massive object warps spacetime significantly, it can bend it so much that it connects to the other side, creating a shortcut between 2 galaxies. You may have seen artistic renditions of wormholes on Google, often portrayed in 2D, but in reality, they exist in 3D or even 4D, resembling a spherical tunnel. Remember the awe-inspiring wormhole scene from the movie Interstellar? Well, it's remarkably realistic. Traveling through a wormhole would warp everything around you, making for a breathtaking journey. However, here's the kicker: wormholes remain purely theoretical at this point. No one has seen one yet. But if they do exist, they could potentially function as time machines. Traveling through a wormhole means exceeding the speed of light, effectively allowing you to leap from one point in time to another.